to do that. All right, you've seen limits before. Actually, probably I don't know. I wouldn't say it's out of order, but we did the derivative stuff already, which required a limit, which I just had to throw at you that you can evaluate a limit by plugging in if you do some algebra, right? Okay, and then we also did these back in the day, so I thought I'd pull these old school questions. And then I don't know what else to say about that. We'll go from there. So, what's the limit as x approaches infinity if this is f of x, this picture? What's the answer to that? It looks like it's around -3. It looks like I went 1, 2, 3 clicks down. And you got to remember that. And I think we'll just have those formally in a set of notes later. Really want to condense this because you've done half of these limits. So stuff like this. Limit as x approaches negative infinity. What's the answer? -3. As x goes to negative infinity, y approaches this horizontal asymptote. And then the idea of having these limits, limit of fx as what does y approach? Remember, as x approaches 2 negative, which means 2 from the left, which actually means what happens when I plug in 1.9? 1.999. 1.99999999999. What kind of number is y going to become? Really big. Sorry, I don't know what that is. Okay, it's a brain. That was my brain going. Okay, and then what happens if you plug in from the right of 2, 2.01, 2.001, 2.00001? What do you get for that? Negative infinity. All right, so you get that. You remember this, right? And then this is actually a quiz question from back in the day. I loved it. I constructed this graph, or found it, and then used this graph to ask these questions. This is one of those rational functions that have some uniqueness going on. Ooh, and then I didn't ask this the second hour, but ask domain and range after this. Ooh. But as x approaches negative infinity, what does it appear y is approaching? 0. I inserted the asymptote, but if I look at both sides, yeah, this is, does it really get close to, yeah, it'll get there. By looking at the other side, that's for sure. So, look at the other side, though. It goes up, hits 0, 0, gets to a high value, and then what does it do? Goes down. So what's the limit as x approaches infinity? 0. It still approaches that asymptote. It's just one of those crossers of the horizontal asymptote. So you remember this. -3 negative. That's negative infinity from the left of -3. -3 positive. Infinity, because that graph, I cut it off because of the picture. The graph goes off to infinity. So these are going to be in some formal questions that you're going to have to evaluate later in the week. I don't have it today. -1 negative. Infinity. -1 positive. And then what's f of -3? That's undies. It's undefined there. That's what the vertical asymptote means. Remember this. There should be some sort of x plus 3 factor in the denominator of this function. What's f of 0? Now that one does. That's just, I asked these f of questions because the students didn't understand them back enough in the day. What it means to have a graph, and it just means when I plug in 0, what do I get as an output value? The coordinate staring you in the face. So what's f of -6? It looks like around -1. Or like -0.5 maybe would be the smallest you can make it. So I just wanted to do that as a recall, and then give me a second, Fumble. Okay, so I think I'll have notes that start off with this exact same statement that we have up here. Is it frozen? Oh, it's not frozen on the internet. It's frozen in class. Boom. Okay, so go ahead and write that down, and we'll talk about it. So all this rigmarole up here, read, read, read. I love reading, Common Core. Come up with your own notes, write about it, so on and so forth. So what does y approach? That's what the limit of f of x is translated to as x approaches this number. Approaches. So what you're going to do, and I know it's going to be kind of silly in the first couple examples that we do, but what you do is you approach that a value from the left, and you approach it from the right. And then you look at the corresponding y values that you get, and you see if those y values are approaching something. And that's how you actually evaluate a limit. That is the rules. All right, so I know the first couple examples, the first one may be a little bit silly, but we're going to make a chart and do that, and then formally do this like we're supposed to. Let me zoom this back down. All right, so take a look at these first two. That shouldn't be too small. Let me go up one more time. Now, first of all, what's this first picture? First. What's this first picture? A picture of a line. Okay, so this is how you're really supposed to approach as x approaches to what is the limit of f of x. You're supposed to plug in 1.9, 1.99, 1.9999. Let's cut off one of those 9s. Okay, and as you plug in those numbers, what do these y values become? It's very simple. Almost 4. 3.9, 3.99, 3.999. So the limit of f of x as x approaches 2 from the left appears to be approaching 4. Now again, I know you know where this is going, and this is, you know, I wouldn't say silly, but a little overdone, I guess. 2 from the right. What are numbers from the right? What? That's me, not you. 2.1, 2.01, 2.001. See, what I'm doing is I'm getting closer and closer to 2 as I do this. So, 4.1, 4.01, 4.001. What does that appear to be approaching? 4 as well. When these two are equal, then the limit exists for the number that both of those are approaching. That is the definition of a limit. And that's how it has to be approached in more complicated questions. Of course, in this case, if I plugged in 2, what do I get? 4. Let's look at the next one, which I think you have been practiced at this enough to know what this is a picture of. But can I plug in 2 into this one? So this is an indication where does it have a limit if the point is not defined at this particular x? And the answer is it's possible. Does anyone know what happens with this graph before I even do it? It's got a hole. As a matter of fact, let's graph this first one. 0, 2, rise 1, run 1, rise 1, run 1. What? I just rise 1 and didn't run 1. Error. Error. And then we can look at, okay, this is how you look at it graphically. I know I'm boring you as the yawns start hitting higher and higher. All right, sucking all the oxygen out of class. 1, 2, 3. As I approach 3 from the left and from the right, this is how you look at this graphically. What does y approach? And those arrows are the key. It's true, right? Sometimes you can look at a picture and just do that. X's, what do the y's approach? Here, I can't plug in 2 and get 4, but it is the line before and after that, because I can plug in 1, 0. And why it is this is really what it gets down to algebraically. I didn't do this the other hour because I didn't have to, but I'm just kind of thinking, you know, that's why we end up getting almost the same picture, except for the hole. So it's the same thing. So if I didn't know that there was a hole, I'd do this, this, and this. I'd still get the same values as the other chart. Pretend this like stood alone, this example. And then plug in this and get closer to 2 from the right. And I still get these. And the whole idea of the arrows can be put on the chart or on the graph. Oops, sorry. I don't know. So approaching from the right, this is what y approaches. Approaching from the left, this is what y approaches. As you approach, did I miss that by 1? How come no one said anything? No, I didn't. Okay, 2. I just got that in my head wrong. This is off by 1. As I approach 2 from the left, I approach 4. As I approach 2 from the right, I approach 4, even though it's not defined at 4. So the answer to this limit is still 4. I know, overdone. Ooh. Okay, 10 minutes? Oh, sorry about that. Two methods that you could use number tables. You can use tables with numbers in it. And you can use graphs, and you can use your arrows. And even though the next examples, I should come up with a real tough one, but I don't have one in mind. What I want you to do for the assigned worksheets, let's move this back. Okay, don't worry about writing this down. Hopefully you get the point. What's the limit as x approaches 3? What's the limit of f of x as x approaches 3 when the chart says, as I do this, I get this, and as I approach 3 from the right, this is what I approach for y. What does it appear the y's are approaching? 1 is the answer. So what are we approaching? What number am I approaching for x here? Ooh. 0. So this goes with this chart. But what does it look like I'm approaching when I approach 0 from the left? What does it look like it's approaching? Negative infinity. Those numbers are getting awfully large fast. What does it look like I'm approaching when I approach from the right? Positive infinity. You know what this is? This is a classic graph where as I approach one, you're down here somewhere, and this one is up here somewhere. I don't know where the other parts of the graph is. So what do you say this limit is? Does not exist. D-N-E. So when you approach from the left, it has to equal what happens when you approach from the right. Okay, you can see we're approaching 3 from the left. What are we approaching for y? What does that look like is happening? What number are we approaching? Infinity. I mean, I could go 2.99999999999. Okay? What happens when I approach 3 from the right? Infinity. This is strange. So what's the answer to this limit? It is infinity. This always blew my mind because you're not really approaching a numerical situation, a number that's finite. But I talked to the calculus teacher and she said it is infinity when they approach the same thing. Left. What does it look like we're approaching? 10. Right? What does it look like I'm approaching? Limit's 10. So that's just how you analyze it on a table. If you have to create your own or not, doesn't matter. It shouldn't be a big deal. You okay? Okay, now I know this is infinitely easy. Oh, wait, let's stop. Sorry. And then a graph. So what's the answer to the first limit? Everybody. 3. Again. 1, 2, 3. Approach from the left, approach from the right. What is y approach? Well, when we approach from the left, this is what we're approaching for y. Approach from the right, this is what we're approaching for y. That number is 3. How about the other one? Oh, no. Hey, what's f of 2, by the way, for this picture? Undies. Okay, but then what's the limit as f of x for f of x as x approaches 2? I'm trying to go too fast. I'm messing up my terminology. Bless you, my child. All right. 2 to the left, 2 to the right, 3. So the limit exists even though the function doesn't exist for the point in question. What's the next one? Oh, no. What happens when you approach 2 from the left? What value we're approaching? Okay, I did actually write this on the, all right, just one more time. Just bear with me. Negative 2 from the left, you get negative 3. Negative 2 from the... Bless you. It's the last one. No more. Negative 2 plus... What do you approach there? Negative 1. These two don't equal, so what do? You cry. Does not exist. You okay? We have an injury. Okay. As x approaches 3, what does y approach? When it does exist there, it's just a number. That's when you're going to find out that you can sometimes evaluate limits by just plugging in the number. Because, when I approach left and right, it approaches what it actually exists for. Then watch out for your questions here. What's the limit as f of x? Of f of x as x approaches 0 for this one. Here's 0. That was quite specific. 4/3. All right. It's reasonable. I yelled at someone for saying like 1.6 because it's like less than half. But anyway, we'll just move on. What about the next one? He's bored. What's this H? To yell at Cooper. Typo. Ruined my notes. Huh? 2. What really should have been asked? Not that it should have been, but you just can't be a robot and think limits are always the asymptote. What's the limit of fx or g of x? Which one is this? How come they're both? I don't know. I'm confused. All right. What's the limit of this function as x approaches -2? What's the answer to that? D and E when they go in opposite directions. I think we've had enough. So what's the limit as x approaches 1? From the left, it's infinity. From the right, it's infinity. So what's the answer? It always blew my mind. I don't like that one, but that's what they say it is. So let's move on. All right, now I know this is Mickey Mouse. Donald Duck. But pretend this is complicated like your homework. Look at your homework that you all have the worksheets. Look at the bottom 6. You see them? Are those as easy as these? Or no? Not even close. Okay, so just pretend. Oh boy, it's always one. Okay, so what does this have? What does this have? A hole. Okay, but let's pretend it's complicated. All right, and then, okay, I showed this to the other class. And then, with complicated, I think I have that one already here. Let's see. I do. Okay. So I have it in from last class. So pretend it's complicated. You don't want to really fill in a long chart. You just want to look at the chart. That's one option. What I did was I typed this in, y1, and let's say I wanted to do this. Okay, so I'm approaching 2. Oh, that says 2. I think we did 3 in the other class. That's funny. I didn't even look at that. All right, screwed that one up. All right, can I plug in 3 as this stands? Yes or no? No. And again, I'm kind of, getting ahead of myself on the algebraic stuff that we're going to do tomorrow. But you can't plug in 3, so the point doesn't exist. So pretend you don't know what the graph looks like, and then you go and look at the graph. All right, I zoom standard. Okay, fine. Why is it a line? Because it has a what again? A hole. All right, so what you can do is a couple things. Say I wanted you to fill out this chart. 2.9, 2.99, 2.999. Say it's complicated again. You can go ahead and hit second calculate value, and you only have to hit it once, and then you can evaluate 2.9, press enter. Oh, 5.9. Interesting. It's not as annoying as yours. Your calculator doesn't disappear every time. 2.9. See how I just typed 2.99? And I'm able to get that. Because you can't set up the chart where it gives you these x values like I have them listed. Sorry. And then 2.99. And then I'll fill out the other ones. And then what would be the other ones here? 3.1, 3.01, 3.001. I don't want to bore you too late. 3.001, press enter, and then that's how you can get this chart filled out. Or you can calculate them on your main calculator screen. Or this one you could do it by hand or whatever. So I think this one's 6.01. I could be safe to say, and this one's 6.1. So what do these appear to be approaching? 6. All right. Now the other class, this was a 2, and I didn't even look at it. What is the limit as x approaches 2? What is that answer? It's actually 5. Just you plug in 2. But we could see and look in the graph that it approaches 5 as it approaches 2 for x through the picture. So may I move on? Well, this is an interesting picture. Thank you, by the way. What happens when you plug in 3? I just want to know. What happens when you plug in 3? What do you get? This is interesting. The answer is -1. What happens when I plug in 2? -1. What happens when I plug in 1? I want these to go faster. They went 0. -1. -1. What happens when I plug in 4? Ah! You get undies. So at 1, 2, 3, 4, that first graph that I did, 1, 2, 3, 4, when I plugged in all those other values less than that, I got -1 for y. What happens when I plug in 3.9999? I still get -1. So here's one piece. All lines are straight, by the way. And then what happens when I plug in 4.1 or 5? What happens when I plug in 5? Now we get what? 1. What happens when I plug in 4.1? I get 1. What happens when I plug in 4? Undies. Step off, Mr. Samuelus. All right. So what's the limit as x approaches 4 for this function? What is it? DNE. All right. So that's a picture where you don't get something cool there. All right. So what are we really supposed to do? 4, not happening. 3.9, 3.99, 3.999, and all these were -1. Whereas 4.001, 4.01, 4.1, all these were 1. So that's what you need to understand there just by plugging in the numbers and evaluating. Last one, kind of a short day, I guess. Hey, this is called a blank dash blank function. Piecewise. Gave you the dash. What's this have an asymptote at? Where's it at? Where's it located? I might get it wrong so quick your head to be spinning. And x equals 0. All right, and then what's an important coordinate that all logarithms have that are not shifted right, left, up, or down? 1, 0. What is the reasoning behind that point? What's ln? But log base e to what power equals 1. So remember 1 comma 0. 0 is the power, 1 is the output. It's reversed. If you change the logarithm back to an exponent is what I mean to say. All right, and then what's the next important point? What's e to the first? So that's 2.718 comma 1. By the way, I made a major flaw, but let's finish the graph. What happens when I plug in numbers less than 1? What do we get for the logarithm? Negatives. As I approach 0, what's the output value become? 0 from the right, -infinity. So here's your picture, but there's a major flaw. I didn't read the piecewise function. What am I not supposed to do for this? Not supposed. What does that mean I have to put in? Everything else. So I'm supposed to put a what here? Whole. And then the function's actually defined for f of x equals 2 at x equals 1. So always these weird little things. Okay, so what's interesting or not, f of 1 equals 2 for the function. But what does the limit of f of x equal when x approaches 1? What y value are we approaching? 0. So again, that's a classic thing. The limit at a certain number for x does not actually have to equal what the evaluation of that number is in the function. I think I said that the way I wanted to. And then this is why I said this. What's the limit of f of x as x approaches e? Here's e. As I approach e from the left and from the right, what y value are you approaching? 1.